say water, because water is moving from a place to another place only. There is no loss. But that's a planetary viewpoint. To a river basin manager, like my colleague, water certainly can be wasted. If water evaporates, he was telling that he considered that this dam that they are planned to build in Mali will cause a lot of evaporation. For their viewpoint, this is a loss. Okay? For irrigation engineers also, it's a loss. But they consider that runoff is not a loss. And for us, runoff is a loss. Okay? Finally, an individual farmer who pays to pump water from a well might view any water that flows off the farm as a waste. And this is logical. You pay for it. Even though that water may supply someone else downstream. That's a quotation of Sandro Costa. Okay, food demand is then increasing. As GDP or GNP per capita increases, people consume more calories. The average world citizen consumes approximately, let's say, 2,800 kilocalories a day. While the average American, of course, America is always top, you know.
We're very big.
But it shows at least the trend,
Yes.
that the development is linked somewhere, directly linked to this kind of phenomenon. Okay? Now, if you want to balance this water, the requirement for food or kilocalories that's coming from food, we need actually by 2050 something like 582 million hectares. That is shown on this video here. If we want to match the kilocalorie requirements and then the food requirements, okay? Because there is only a negligible amount of undeveloped land that could be farmed without irrigation, and because the yield on irrigated land are greater than on non-irrigated land, farming more land using irrigation will become a necessity in the coming decades. Okay. Now, if you say more irrigation, it means more water. And you need more water. And then here is where comes in the question of efficiency. If we were to continue using gravity irrigation or traditional irrigation or over inefficient methods in 2050 at the same level as we use them today, agriculture will consume virtually all of our available fresh water. Okay, then this is the gap. If we use traditional techniques, the gap is here, somewhere yeah, you can see it here, some, let's say, this is let's say almost 2,000 billion cubic meters. That is the gap. What solution for irrigation and yet no water scarcity? Agriculture has the greatest potential for solving the problem of global water scarcity. And we know that, I say that it's almost 70% of withdrawal. Different methods have been suggested to reduce evaporation, but they are expensive. And most of the time, it's not affordable for especially developing countries. And filtration can be a major problem in reservoirs and canals. But you can also line these canals, and this is also very costly. Now, where to find a solution? We think that the correct water application rate for efficient irrigation, avoiding deep percolation, is the solution actually for this. Technology offers two modern methods for irrigation efficiency. We have two: mechanical move and subsurface drip irrigation. Employing these modern irrigation technologies appropriately is key to overcoming the critical challenge of global freshwater scarcity. Okay, this term stands for mechanical irrigation, mechanical move irrigation. irrigation actually is MMI, like here, with LEPA, low energy precision application, and subsurface drip irrigation. These two techniques, so MMI and SDI, more or less relations. This is MMI, okay? This is MMI, the way we apply water to the field is through this LEPA, that's a kind of sprinkler, but actually bringing water by bubbles, very small discharge, and very localized application. This eliminates the deep percolation. The wetted area, you can see here, is smaller, and it achieves 95% of efficiency and better crop yields. If you compare to a traditional method, that is, for example, here, furrow irrigation, what we call here irrigation à l'arrêt. Furrow irrigation, because of the sloping land and that you are taking water from upstream and it will flow to downstream, it's different. This one will move. I will show more details. You have this LEPA. You see, you have LEPA 1 here. Related. You can change the way water is flowing out of these sprinklers. You can spray irrigate. This is bubble irrigation. You can chemigate with application of water and chemicals or fertilizers on the foliage, even from down to up. So you apply the chemical or the fertilizer on the downstream side of your leaves. This is something that you can do with LEPA. Now, these sprinklers are connected to the machine like this. You can see here dropping down these narrow pipes, and at the bottom of this you have these apparatuses. And you apply water very close to even very close to the ground if you want. This is a very efficient way to irrigate. And we think that's one of the way to have efficient irrigation and solve the problem of water scarcity. Okay, you have a sketch of this here. Okay, you have these towers, what we call towers, and let's say the total length of this machine can reach 1,000 meters. 1,000 meters, but the most common is around 500 meters. Okay, SDI, that is the subsurface drip irrigation. Also, is a technique applying water very local water application. This is a subsurface one, and then you remove the possibility, or you reduce a lot the possibility of evaporation and also of deep percolation, because you apply only the water depth the crop needs in the soil. And this is one of the drip irrigation techniques. And this one, we will use it for vegetable crops, and that one for trees. So you imagine that you take a line, what we call lateral, going maybe 300 meters. And at every 2 meters you have a crop, maybe an apple tree or a citrus, etc., etc. And you have this application technology. Thank you for your attention.